Okay. And thank you everybody for joining us for another one of the Siemens SINUMERIK webinars. Today we're going to get the opportunity to explore the world of service and maintenance a little bit more. You notice we did call this webinar 201, so this is building off of a previous webinar we did a few months back, just kind of introducing you to some of the topic of service and maintenance. So here we're going to delve certainly a little deeper into this topic. Oops. Good. Sorry, too many buttons. So just to introduce myself, for those of you that may not know me, my name is Chris Pollock. I am the manager of our Virtual Technical Application Center. So I get the pleasure and the privilege to put together and work with a lot of my colleagues as well. And we develop a lot of this web-based material that you start to see. So whether it be the webinars or our YouTube live events or whatnot, I get to kind of drive a lot of those initiatives. So for sure, I am absolutely a resource here for you to help you guys out with kind of all things operation and programming based. And certainly we get into some service too. But if it gets deep, then we can always lean on the vast number of highly technical Siemens people here in the US that can support us more from the service, heavy service, and more likely commissioning side. But by all means, I'm a resource. So if you need me, feel free to reach out. Now, before we get into the primary content, I do like to get a quick chance to plug for those of you that aren't familiar with us, and maybe this is your first time here. One of the key websites you want to check out from Siemens, that's this us.siemens.com/CNC for you. On that, you can get links to all of the webinars. We have all kinds of training material. And one of the new things that we've just added in light of a lot of the current situation with COVID and making it difficult for people to travel is we are now offering online trainings, instructor-led multi-day training segment. So if you would like to expand your knowledge of the SINUMERIK product line, we're specifically offering programming and operation classes. We have 2 level 1 classes that what we have available now. It's the shop mill and shop turn classes. And then we have 2 different level 2 classes, which gets into G-code programming of a milling machine or G-code programming of a lathe. And then moving forward, we will be building off of that. So if you're interested in checking out some of our online classes, by all means, navigate over to CNC for You. You see under the training section, you'll get to this page and just click on the online training. And again, these are instructor-led. So this isn't like a self-paced learning where you're just going to kind of have to navigate it through yourself. You work with either myself or one of my colleagues, and we get a chance to truly dig into the product. We also have our Mr. CNC YouTube channel. So if you haven't seen it, check it out. You can just go over to YouTube, do a quick search for Mr. CNC. We have a whole library of material that's been put up there for you. We do have the webinars being hosted on that platform, but we also do a lot of stuff to the YouTube channel. So we have our own live series. We call it Simply SINUMERIK Live. We try to run an event usually about every 4 to 5 weeks. There's also a lot of promotional videos and little how-to videos. So if you haven't seen it, certainly check out that channel. And we also offer a service we've been talking about for the last few webinars here. We call our Virtual Product Expert, or VPE sessions. And that's the ability for you guys to schedule time with one of our product specialists and dig into topics usually centric to operation and programming. So if that is something that you would like to explore, you can certainly always reach out to Danny Vitullo. Danny does manage the program, but additionally, on that CNC for You website, there is now a virtual product expert link under the CNC training. So if you would like, you can also just put a request in there. It'll get sent over to Danny, and he can reach out to you and set up a time. Typical segments are usually around an hour, so you kind of give us a topic you're interested in, and then we get to have a live meeting and discuss and dig into the topic with you. But without further ado, I would like to say hello to Steve Holmes. Steve, how we doing?
Doing just fine, Chris. Still wearing a mask.
I see that. I'm proud of you.
Yeah, I think until Dr. Fauci tells me that, Steve, it's okay not to wear the mask, I'll continue to wear the mask. So
Well, there you
there you go.
go. That's very very good of you for sure. So Steve actually joined me the last time we did the Service 101 segment. So a lot of you may already be familiar with Steve, but if you're not, Steve's a colleague of mine. Been in the industry for, as you see, for well over 30 years. A wealth of knowledge, not only from the operation and programming segment, but also knows a lot about the service topic. So Steve and I are going to kind of jointly work through this webinar. We're going to get a chance to use some of my resources over here in my studio with some real life examples of the machine, and Steve's going to go through a lot of the theory. So without further ado, Steve, I am going to switch it over to you. Give us 1 second here as we transfer power. All right. Good. Steve, you should have it. Looks like you are getting ready to share content. Yep, and we see your screen.
Good.
Oh, perfect.
Good news. So since it is the middle of January, I think I would be remiss if I didn't ask Chris, since he's in New York and I'm in California, I would be remiss if I didn't ask him, how's the weather out there in your part
And
of the country?
the weather isn't too bad. It's chilly, but it is January. Looking forward to getting on the skis here maybe next weekend. But not much snow on the ground, honestly. Just a little wisps of it here and there.
Yeah, that's a shame. A little
And
chilly
you're
out
probably
here.
swimming.
Yeah, right. A little chilly out here in Southern California as well, but it should warm up to be about 80 today. So
All right, yeah,
not so
don't
bad.
rub it in.
We'll just live with it, I guess, as we go. But again, thanks, Chris, for this opportunity to co-host a webinar, and also welcome everyone, and thanks again for joining us today as we explore two primary topics. The first topic is servo tuning utilizing the onboard tools on the control, otherwise known as AST, and then also the circular test. Chris will demonstrate these tools on his machine along with a simple procedure for checking and adjusting the backlash. Secondly, we will dive into how to view the states of various I/O, both on Sinutrain, which is our offline software simulator, and also on the physical machine. So also at the end of the session, don't forget to stick around because we will host questions and answers, and feel free to post some questions on the chat window as we go through the presentation. Okay, by now, almost everyone viewing this is probably familiar with the 828 and the 840 line of controls from Siemens, but many of you may not be aware of the new addition to the SINUMERIK family, and that would be SINUMERIK 1. We at Siemens are very excited about the latest addition to our family, and really this is the first control designed from the ground up for digitalization and the digital twin. So both of the topics that we explore today will apply directly to the three controls shown here, all using the SINUMERIK Operate HMI. So one of the main differences between these controls is the PLC. The 828 on the left uses step 7-200 PLC, and that's designed mostly for simple and common machine tools like mills, lathes, grinders, machines like that. The S7-300, which is you'll see on the 840 control, is a much more sophisticated PLC capable of very complex tasks and functions suitable for high-end machine tools, also incorporating robotics and automation. And then finally, the SINUMERIK 1 incorporates the S1500 PLC, which uses TIA Portal. TIA stands for Totally Integrated Manufacturing, which means its capabilities extend far beyond the machine tool itself, and can also be used for integrating all the aspects of your manufacturing process throughout your entire factory and even the building itself. So if you think about the possibilities of the digital twin of your entire factory, that gets pretty exciting, and this is the future of manufacturing. So we're going to get started with circular and the auto servo tuning tools. Certainly, these are two different tools, but they're closely related. The idea here is to perform a circular test to establish a baseline, then do the auto servo tuning to obtain maximum performance, then another circle test to compare the original test. Okay, so things to know before you begin. So, Chris, what would you say are the three most important things to remember before getting started with any servo tuning or changing of machine MDs?
Well, I'm certainly glad you asked, Steve. And from my mind, it's very simple. Backup, backup, backup. Make sure you do a system backup before you proceed with any of this. That is certainly a lifeline that you have, that you may need.
Great answer. Okay, and also, before you make an archive, you also want to, it's always best to return the tools to the magazine with a tool 0. And then you also want to check for the mechanical issues on the machine, things like backlash, mechanical binding, misalignment. The machine should be run in, meaning it should be warmed up, and the lubrication should be, it should be okay. So, you know, for the best results, the machine has to be in the good mechanical condition. Otherwise, you could just be applying a Band-Aid to an underlying issue that should be addressed beforehand. In other words, the test might not be legitimate, or certainly you're not going to be able to obtain the maximum results from the testing. So you're also going to want to perform the optimization at a realistic motion, position, and load. So ideally, the center of travel is a pretty good location to start the testing, and the load should be representative of the normal load on the machine. So what that means is if you generally have like say a rotary table or a big heavy fixture or heavy parts, and you're putting 1,000 pounds on that table, you don't want to perform this optimization test on an empty table, because you're not going to get the results. The results vary greatly depending on how much weight is on the table. And the next thing you're going to want to select an optimization strategy, either maximum, moderate, or conservative. So by strategy, what we're really referring to is what is the responsibility, or how robust do you want the access to be. And last but certainly not least, don't forget about the Siemens hotline available for assistance. So we're going to do a brief review of the different modes of operation. So in order to navigate to the service or the diagnostics screen, you're going to select either the upper right hand corner of the screen, or if your keyboard is equipped with a manual select, you can select that. So that's going to bring you this bottom row of horizontal soft keys. So we're going to talk briefly about the different modes. So the machine mode displays the information such as the axis position, distance to go, feed rate, spindle speeds, active tool, etc. And it also includes functionalities such as manual tool selection, tool workpiece measurement, hand wheel, or anything having to do with machine motion, such as the jog functions or running a program in auto. The parameter mode displays information such as tool magazine data, work offsets, user variables, anything having to do with tool management. And this is where some guys get a little confused, because what some manufacturers refer to as parameters, in the Siemens world, we refer to those as MDs, or machine data. So it's important to make that designation. So also the program and the program button and the program manager, those are used for creating and storing programs. Now, the diagnostics mode is used for diagnosing machine problems, information about current tests, alarms, status of drives, access networks, and NC PLC variables can be viewed. It is also possible to check the software and the hardware versions of the system in the diagnostics mode. The setup mode is used for a wide variety of functions, but not limited to password entry, machine data, modifications, creating archives, creating alarm files, time, date, settings, network setup, license options, system data management, and of course, servo optimization and MD. So we will be working in these two primary modes of operation, both in the setup and the diagnostics. Okay, as we go a little deeper into the navigation for service, we're going to look just at the service overview screen just to get an idea of our measuring systems. And we're going to either select the menu select or the upper right-hand corner. We're going to navigate to the upper right-hand corner of the screen. That'll get us to the diagnostics area. And if you don't see this screen that we're looking at now, you just simply press the arrow key here, and then that's going to bring you to this screen. And from here, after checking to see what is the active measuring system, either 1 or 2, in this case, it would be 1, which is generally going to be the rotary encoders, and measuring system 2 probably would be a linear scales if the machine is equipped. So if we select the service axis key here, that's going to get us into this the screen on the right side, and there we can look, we can see all kinds of useful information in real time. Things like the following error, contour deviation, what is the servo gain being used, the status of the active measuring system, and all kinds of useful information. And while you're in the screen, two key things to remember. One thing, you always have access to the onboard help by pressing the help key. And the other is you always want to make sure you're looking at the right axis. So you select the axis by these vertical soft keys. So here we're looking at a couple of plots from 2 interpolations that was done actually on the machine using the onboard tool. So in this plot on the left, we can see that these axes are not synced. So we have this egg-shaped, or actually peanut-shaped plot. So that means that the axes have different following error, or one axis is lagging behind the other. And then on the plot on the right, we're actually seeing where the axes have been matched. So they have identical or close to identical following error. So those axes are in sync. This next slide shows a pretty interesting comparison between a plot that was developed from a part that was cut on a machine and then brought over to a CMM. And then the plot on the right was a screenshot taken exactly from the control on the machine using the onboard tool for the circular test. And we can see that the error is almost identical. The plot is almost identical. So that gives us an idea of really how accurate the tool is. So we can see that the reversal spike right here at the apex of this arc, or actually before the apex of this arc, is at the same location on both plots. And if you were using a Renishaw ball bar, you're going to get very similar, almost exact results. So it is a very useful tool. But it's also important to recognize that if the machine has linear scales, the tool is going to be a lot more useful and accurate as opposed to just relying on the feedback from the rotary encoder. And in this case here, we're actually looking at a reversal spike. So this machine had scales. If it was a backlash value, that would be designated by an outward spike instead of an inward spike. And what's also interesting about this particular plot is that it's actually before the apex of the arc, and that's really quite unusual. And the reason why in this particular example is likely because the compensation was incorrectly applied or applied at the wrong location. So those are things to kind of be aware of when you're analyzing a plot. So in order to navigate for the circular test, it's the first thing you would do again is navigate to the upper right hand corner of the screen, or if your control panel has a menu select button, you can certainly use that. And then when you select that, you're always going to get this this bottom horizontal soft keys displayed. So you're going to press setup, and then you're going to go to optimize test, and then finally to the circular test. So from there, we're going to go right back over to Mr. Pollock, and he's going to demonstrate the circular test on his machine. So take it away, Chris.
All right, perfect. Great setup so far, Steve. Good job. I'm switching our system over, and I hope you guys will have to bear with us. We just have to bounce back and forth a little bit. So you guys should have me here, and welcome into the VTech studio. So for those of you guys that maybe haven't seen my pretty face before, hello, hello, hello. So we're gonna get a chance to play around with our machine, kind of try some of these tools. Certainly we went in there and we induced some error, obviously to give you something to look at, because this is my machine, so this would normally have an error, right? This is as perfect as I can make it. But all kidding aside, let's kind of dig in. So, you know, when we started talking about this, this scenario, this case, what would be like a viable use case that an end user may run into, or a service technician, or maybe somebody working for the factory? So let's say, for argument's sake, you were cutting a pocket, doing some circular interpolation, and you're running into an out of roundness, right? It is out of spec. So generally, any of us that have had any time as being a machinist would know, okay, I'm going to drop an indicator into this bore, I'm going to sweep that bore, I'm going to take some measurements. But now I got to kind of figure out and determine, well, what's the next steps? And that's where we can start to use the circularity tool. Now, it is important, it's mentioned, you need to know whether your system has glass or not, because the results you see will differ a little bit. So preferably, if you happen to have a machine with scale, then you're truly seeing the motion between your two linear axes. And you're not seeing any form of compensations per se that could be happening at the motor that I may not be really seeing up at the table. So what do I mean by that? Well, backlash comp's a perfect case scenario, right? If I have everything tuned properly, I would not expect to see any jumps or any spikes at my axis changeovers. However, if I'm only looking at the motor encoder, I'm always going to see some kind of a jump, because the motor is actually going beyond the position to overcome your backlash, right? Your lost motion, then coming back. So just keep that in mind. My machine, I don't happen to have scales here, so we're going to be looking at this purely off of the motor encoders. So as Steve said, if you're not sure what system you have, go to your diagnostics or your alarm screen. You want to expand over until you can find your axis diagnostics. And inside the axis diagnostics is this first reference page. At the bottom, it tells you your measuring systems. And here you can see on my first measuring system, which you will always have, because we always need to have a motor encoder based off the motor, you'll see these check boxes. But down below it, I have yellow boxes here because I don't happen to have a scale feedback. Sometimes you'll have a mixed scenario depending on the machine, so it's not uncommon on a 5-axis to maybe see scales on your linear axes, but not on your rotaries. That's possible. But it's a good thing to go here and know that. So the next step would be, how do I actually use and get to the circularity test tool? So I've come in, I'm going to go to setup. And I can zoom in a little bit here if it would help you guys. You tell me, Steve, that look a little better? Maybe it's easier to see the screen?
That's perfect. Thanks, Chris.
No problem. So when you get the setup, you want to go to your optimize test horizontal soft key. And that's this corner key in the far right corner. And when you come in, now you have a series of options along your horizontal soft keys. We're going to be primarily looking at 2 buttons throughout this webinar: circularity test and auto serving. So if I go to circularity test and highlight that one, it's going to bring me to this screen. And really what this screen is doing is it's setting up the condition of the test. So I'm going to define which axes I'm measuring. So in this case, I want to look at the X and I want to look at the Y. Don't let the MZ or MY fool you. If you were to look into the machine parameters or MD, as Steve mentioned, you would see that axis designation. Just determining the x-axis. I had a secondary measuring system. You can only ever look at and kind of get over to this active field right now. Radius. Now, certainly, if I'm just using this as a health check, and I didn't necessarily have a cut part, but I just want to do a little intern test and see how. Then I can put a larger radius here. Certainly, the bigger the radius, the more deviation we're going to see. But if I'm comparing it to a cut test, like I was doing on this part, I would want to use a radius similar part I was cutting. Additionally, I would probably want to use a feed that is common to the cut condition I'm trying to duplicate. So in this 50 inches per minute, you do have a multiplier factor here. That will change the sampling time or how long it takes for the measurement. Usually I'll leave it at 1. When I run it, I'll look to see to make sure it got all the way around the circle. And if it didn't, I can change this multiplier. And then we have the resolution of the graph once we're all said and done. This is basically the distance each line will be. So I come in. Now I need to send the machine into a circular pattern. I need to get the machine moving around. So what you want to do is you want to jog the machine so it's roughly centered in its travel, because it is going to be doing a 2-inch diameter circle in this case, since we have a radius of 1. Now, as long as I'm running, and I think it's version 4.7 when we started allowing the system to auto-generate the program, I can actually create a part program to do the test by hitting that generate circle program and saying, load program mode. If you're running an older version of software, you'll have to pre-create a particular program and let it just keep looping in the background, and then you can take the test while it's spinning. But in my case, I'm going to switch the machine to auto. Cycle start. It's going to run that program that was just generated by the tool. And then I just want to, I can hit start now, or I can go over to graphics and hit start. Doesn't really matter. If you use the graphics button, then it'll just pop up the screen when it's done. You see this little kind of bar, status bar across the bottom. That's what's giving you the indication of how long it took to run. And now we start to see the results we're getting on this part. And I can even jump to a full screen, make it a little larger. So there we see some distortion, we see some spiking, and we can start to explore maybe some scenarios on how we could compensate for that. But with that being said, I'm going to...
It's not a very good looking circle there, is it?
No, I think I did a pretty good job of messing this machine up. I believe so.
Perfect.
Okay. So we have some data, right? So why don't we jump back to Steve? And Steve, you can start to talk about how we can analyze that data a little bit. What are some of the steps we can do to possibly correct it? So let me give you over power or control here. You got it. And the floor is yours, my friend.
Okay.
Good.
Good.
We got you.
Perfect. Okay. Thanks, Chris, for that that demonstration. I think that was very useful to actually see how that's done. So I think the first thing that we're going to talk about is the backlash, because if you notice on the apex of the arc and Chris's interpolation test, there seemed to be a significant amount of backlash, as well as the drives not being in sync. So in the backlash test, again, as Chris mentioned, we're going to make sure which measuring system is active, because when we go in there and adjust the MDs, we want to make sure that we're setting them correctly. And this is on the right side of the screen. Here's a simple program that's used in order to check the backlash with an indicator. So it is kind of important that you use a program similar to this, because that's going to be the most accurate way of measuring backlash. It still is considered somewhat of a static test, as opposed to like on a ball bar or a circular test on the control, where that would be more of a dynamic test. But what a lot of guys will do is use the hand wheel to check for backlash, and you can do that for a kind of a quick look. But you're going to get better, more accurate results if you use an actual program similar to this one that's displayed on the right side of the screen. So here we're looking at some of the backlash machine datas. So you first wanted to be aware of what is the encoder type. And here this says 0. So 0, this screenshot was actually taken from Sinutrain, my offline simulator. So I don't have physical encoders, so this was set to 0. But generally what you're going to see with encoders is this would be set to 4. So that would be a general absolute encoder with the NDAT interface. So the screenshot on the right side, we're looking at where the actual machine datas are for Backlash. So machine data 32450 index 0 is where you would enter the Backlash value, either positive or negative. It's extremely rare where you're going to actually enter in any negative backlash. So most of the time that's going to be a positive value. And the next thing to pay attention to is the index number 1, which would be if the machine had linear scales and you were attempting to put some backlash in for the scales. If that was the primary source of feedback, that's where you would change it. But it's kind of important to recognize that with linear scales, as opposed to rotary encoders, there should be very little or almost, in theory, no backlash if the feedback system is functioning correctly. Okay, so now we're going to go right back to Chris, and he's going to demonstrate the procedure for testing Backlash.
Perfect. So while you were talking, I had a chance to start setting up for our Backlash test. So one of the things I did here is I certainly grabbed out my indicator in my mag base, set a 0. So I just moved into some datum surface. A lot of times I like to use the spindle cartridge. It's quick and easy. If I am measuring up against a radius like this, personally, I like to find the high spot of the radius. So this way I don't get any kind of a funky measurement if I'm coming off the side of the spindle. So just jog the X back and forth until you see the high point. Once you're there, move in the Y, because in this case I'm going to measure the Y. Set yourself up a quick 0 so we can move from that. And as Steve mentioned, yes, you can use the hand wheel to start to see what happens with Backlash. So if you take a look here, let's say I'm going to move this machine at a 10th. Moving at a 10th, you guys might be able to see that. Let me go to the other screen so the indicator's a little bit bigger, right? But now when I reverse direction, boom, I get this big jump. So I understand what's going on, but you know, you have very different dynamics in play once you start moving in the program move and kind of breaking the friction that's there and getting away. So preferably, we do want to drive the machine around with a program in park program mode. So what does it consist of? Well, once I have my datum, then I'm going to go over and I'm going to create myself a very simple little program. Here I have one built for us for testing the y-axis. And what I want to do is I just really want to start it with a position move, and I want to do a feed move here, going to a y of 0. Give yourself a chance to see the measurement and let the indicator settle out. So I put in a quick dwell of 2 seconds, so that's a G4 feed 2. Then I want to do a large move away, right? So I'm going to break kind of any friction there. So, and this is large relative, right? Relative to the move that I'm going to be loading the indicator by. So I'm moving away an inch. You could go 2 inches, 3 inches. It doesn't really matter. It's up to you. But from there, once I get to that inch, I want to immediately turn around, come on back to my 0 point, and then I want to stop. And then you can certainly just use a dwell here as well if you're just going to keep this thing running, or you can put a program stop. I have a program stop here, so we can kind of see and look a little closer and get a chance before it does its next move. But this is really the important one now. So I brought back the indicator to 0, and now I want to load into the indicator and then come back. So the distance of this move is obviously dependent on the range of your indicator. In my case, this is a 10, so I don't have a ton of range, but I can certainly go 10,000. So I'm going to load in 10,000, and I'm going to reverse and come to 0. And then the difference of my previous move to 0 and my now current move to 0, that will start to show me my backlash. So if we go over to auto, And then we just keep looping that and we can test it. Now, I'm probably going to do the test, even maybe prior to going into my MDs, just to see what I have. And then we're going to look to see if the system was compensated with. So cycle start, machine's going to move away. There's your big move. Repeats back. This gives me a chance to see the indicator settle out. And she reverses. And there I start to see, and hopefully you guys can see it too, I'll do it a few times, where I'm actually overshooting. So normally with backlash, when I come back or I turn around, cycle start, I turn around, I expect it to undershoot that value, to not quite get there. But since I've overshot, that means that I'm overcompensating for my backlash. That's actually a pretty common scenario on a brand new machine as she settles in, because a new machine, like anything, is a lot tighter when it gets first installed, right? If it's a boxway machine, the gibs kind of have to set in. Even a linear rail, the linear rails themselves will kind of wear in a little bit. If it's a grease system, the grease will start to kind of absorb, and you won't have quite as much resistance. So what was a valid compensation data at the brand new point, well, maybe a little bit aggressive. So here is where I want to now go into my machine MDs or my parameters. So we go menu select, setup. I want to back out of my circularity. This is what we're looking at here, by the way. That's that spike that Steve was talking about. So that's what we're getting right now. So if I back out, we jump over to my machine data. I want to navigate to the axis data, make sure I select with the plus or minus keys the appropriate axis. So I'm looking at Y, and then I can just use my search to search down through into parameter 32450. And you can just type in backlash if you don't remember 32450. Now, as Steve mentioned, it's important to note what I have going on here as far as my number of feedback systems. So since I only have one feedback system, I'm certainly going to only enter the backlash into index 0. And I start to see now I have half a thou of backlash already compensated in this axis. So to really start to see the true backlash, I want to zero out the value. Now, whenever you make any changes in here, it's important to note the state of this symbol, right? This is what's telling you what it takes to activate that parameter. And a CF says you must press that button to get that value to activate. And if we watch the indicator, you guys can see it. And let's say I put a number in here. See how the indicator actually jumps? Do you see that, Steve?
Yeah, that's interesting that you can actually do that in real time and make those and see those changes on the indicator as you're changing the values.
Absolutely. I mean, I'm still actually running the program now. So you can actually make things change on the fly. You just can't implement any of these CF values if you're at a program stop or you're in a reset condition. But you don't have to actually be in a reset. So right now, I can hit cycle start, and my machine, you're going to notice, is going to start moving. And there she goes away, right? And there it's coming back. So now if I kind of watch, I'm at roughly a half thou. I come back. I undershoot the half thou by maybe 2/10. And I move away. So I don't have to worry about re-zeroing it. I'm just going to use half thou as my reference point. But now I can start to see, legitimately, I got about 2/10 of backlash in this machine. So while I'm sitting here, I can make my change. Now, if you're getting to a scenario where you have, you know, a decent amount of backlash, thou and a half, usually whatever I read here, I typically like to use about 70–80% of that value. We're only talking about tenths. This is a pretty tight machine, so obviously I can probably comp it right to the full value. So we'll go move our next move. So now my reference point is 3/10 off the 0. And as I back it back and forth, I see that I'm pretty much hitting that right on the mark. So I'm pretty comfortable that that is a good compensation point for this. Now, if we were to rerun the circular test, which we will do later, we will still see a little spike there because we're looking at the motor encoder. But what we'll see is we'll see a 2/10 spike. And that's a needed spike at the motor because it does have to do a reversal. But that big spike is going to come down quite a bit. Good. So with that said, let me jump back to you, Steve. And you are back.
Thanks again, Chris, for that demonstration. It's very helpful to actually see that being done in real time.
Absolutely.
Okay, so now we're going to get into auto servo tuning, or the acronym for that is AST. And a word of caution before we get into that. So in auto servo tuning, there's actually going to be some changes made to the parameters as it's going through the tuning process automatically. So that's why it should really only be done by qualified technical experts, and you should also check with the machine tool builder to kind of determine what strategies they use when tuning their machine. So you got to be real careful there, because you can absolutely create some problems that didn't exist before if you're not sure what you're doing, or you're not sure what the builder's intent was when they initially optimized this the machine. So just and also that's another reason why we make archives.
Exactly.
Okay, so we're going to just dive just a little bit into the theory behind what the auto servo tuning is doing. So we're looking at the servo drive loop, or the interpolator. So what we're going to do is we're going to optimize the speed controller and the position controller. So the speed controller is shown here, the position controller is here. We will not be optimizing the current controller in AST. However, we will be looking at those, or the AST will look at those values in determining what adjustments, if any, need to be made to the position controller or the speed controller. So each axis is measured and optimized separately, and then when that's done, then the lag, which is also known as the following error, is matched on all of the contouring axis. So by contouring axis, in the case of a 3-axis machine with a spindle X, Y, and Z, even though you can optimize the spindle, and it's recommended in some cases that you do, because the spindle is an axis, it is not a contouring axis. So the KV factor is determined by this simple equation on the right, which is basically the speed divided by the following error. That gives us the KV factor, or otherwise known as the gain for that axis. So the following error is nothing more than the difference between the nominal position value and the actual position value of the active measuring system. So what we mean by that is the nominal position that's where the machine should be at, and the actual position is where the machine is really at. Okay, so in order to navigate to the optimize test functionality, we are going to first navigate to the upper right-hand part of the screen. We're going to select that. We're going to go back into setup exactly as we did when we did the circular test. We're going to go to optimize test, again the same, but instead of selecting circular test, we're going to go into the auto servo tuning. So with that, we're going to jump right back to Mr. Pollack, who's waiting patiently at his machine to kind of show how this process is done.
Perfect. I do want to apologize. I am seeing some of the people are mentioning that the audio is choppy. Have you been hearing that from your side, Steve?
A little bit, yeah, a little bit. I mean, it's it could be better, but we're getting most of what you're saying. I think we can follow along quite well, although it is a little bit choppy on my end as well.
Okay, I'm looking to see if there's anything I can do from an audio setting standpoint.
Is that a Bluetooth headset you're using?
It is. We could be getting some interference. Flying filter before we started here. I'm wondering if it works. Because the fans on the machine are a little noisy. So sometimes we can cancel that out. here we go. Let me, I'm going to get rid of that, and you guys tell me if it sounds a little better. So I am now getting rid of that filter. Okay, so let me, I switched over to myself, and let me just share my screen. So now we're going to talk about auto servo tuning. And exactly to parallel what Steve is saying is you do want to proceed with caution when you start getting into servo tuning. The last thing you want to do is start applying some tuning strategies. You're not sure what's going on, and you make the machine worse. And for sure, you know, the archive can get you out of that, but you certainly should be comfortable enough knowing how to load in archives. There can be some processes that have to take place depending on the machine builder and the way they set up their machines and some of their safety integration. So again, I would say, you know, if you're a service tech, you work for an OEM or an importer, this topic, this kind of feels right into your skill set. But if you're an end user, I would certainly reach out to the OEM before you proceed with making any kind of changes to the system. Okay. Is it the audio any better, by the way, Steve?
I would say it might be a little bit worse than it was before.
A little bit worse. Well,
Yeah.
then I would rather switch that real quick before we get any further. So let me change that.
I mean, it goes in and out right now. It's
Steve,
perfect. So,
yeah, you know what it is? I'm turning my head, and maybe the range of the Bluetooth is a little weird. I'm gonna have to. No, darn it. Can I do that before I get started? I don't want to waste a lot of you guys' times in our technical issues.
well, that's part of the joy of doing it live.
Being live. Right? Yeah, absolutely, yeah. Absolutely. And unfortunately, with WebEx, I can't use the same hardware that I use for my YouTube lives. So it's been a little challenging. All right, I'm going to put the filter back on, and hopefully, if it gets real bad, just jump in and let me know, Steve, and we'll.
I think it's workable the way it is.
All right, I do apologize.
It's just not up. So that can all be edited out in post-production, right, Chris?
No, no. Okay, so we're back at the machine. So we want to start to explore the world of auto servo tuning, right? So we're going to jump back into the optimized test soft key that we were in before, and we're sitting in our circular test. And now we want to press the auto servo tuning button. Now, this is exactly why you want to kind of proceed with caution. So if you look at my machine screen and you see axis optimized on different machine. So that could be a scenario where the builder is using a standard set of parameters that they optimized on their first prototype machine, and then they're just dropping it in the production run, and they're not going through all the steps of actually optimizing every single machine by itself. That is a very common and absolute good strategy. There's nothing wrong with it, especially on a machine like this that's really, this is more of a general purpose machine tool. Certainly it's not a high-speed linear motor machine tool. And why you want to be careful is you could choose a different strategy than they originally implemented, and all of a sudden your parameters could start fighting each other. So we're going to go through the process steps, but once I see this, I would really want to tune every single axis based on my strategy right now on this machine. If I was a technician and I was going to kind of go the next step and try to optimize this machine at the customer's facility. So step one. Define your strategy. So you want to highlight the axis you want to optimize. In this case, I'm highlighting on Y. I'm just going to do that with my blue arrow keys, or if you have a touch screen, you could touch the screen. You're going to select the strategy button, give it a second to build, and now you're going to have 3 different screens where you have to define your strategy on. So first, we have our axis strategy, and you can see we have a bunch of selections. So typically, if we're going to come in and we're going to fully optimize or check and adjust the axis, especially all the axis, I would want to choose this second selection down, this 102, which is measure and return both a speed and a position control. The default was, not default, but the one that was selected previous to probably when the OEM optimized, was just measure and return only a speed control. So that's a good reason why I would want to make sure that I would go through each of the axes, because my results could be. So we choose 102. Now I want to go to the speed option. Here, I'm going to come in and I have, again, some options there. So I want to use my 303, which is my width reference model, and my reserve. That happened to be the one I selected. And you can choose how aggressive you want the tuning to be. So we have conservative at the very bottom. That's going to be the softest tuning response. We have a moderate, which is what I'm going to use right now, and which is we typically would recommend on a standard machine tool like this. And then I have a maximum responsiveness. So certainly if I have that we are really trying to get some serious performance out of, then we can start to take a look at the maximum. But generally, we do recommend a moderate, unless I have a really big machine with a lot of heavy dynamic load, and maybe even a moderate would be too aggressive, and the machine would become unstable. So then you could use a conservative. And as well, selections here. So in this case, we always do recommend working with 203, which is your maximize your KV with no speed step point filter, and feed forward would be on. So we highlight that one, 203, and I'm going to maintain a moderate response. So select OK, and now that is the strategy she's going to use. Now what I would suggest is you go through tuning each axis, and maybe I pick X, double check that same strategy. You don't want to pull a previous strategy that may be different now that the OEM could have used, because there is a back-end file that gets written. Once you do that, now we're going to select the tune option. And I need to put the machine into jog. And it's going to prompt you pretty good as far as what it's asking you to do, right? So it asks me to put the machine into jog, then move to this next screen. It's making a couple recommendations showing where you are in the travel. You want to be centered in your travel. You select OK. It's going to take some measurements in the back end, and before anything really moves, it will prompt me to do a cycle start. So now it says press NC start to continue. I hit cycle start, and now it's making its first automatic measurements. So this is what we refer to by the auto portion of auto servo tuning. There certainly is, plenty of steps you want to do from a setup. Don't confuse auto servo tuning with easy servo tuning, because it's not easy, right? But it is certainly a lot easier than doing it manually. Okay, so she takes her first measurement, shows you a little loading plot. Then I'm going to hit a second, and measurement's going to be a little more aggressive because it's trying to basically get the axis unstable, so it kind of knows the thresholds that it can apply to keep the machine in a stable state and get the most responsiveness we can out of the servo within the conditions you choose. So you guys are probably starting to hear the noise. You hear that, Steve?
Yeah, we start to hear it a little bit. Yeah, that's that machine oscillation, right?
Absolutely.
Squealing a bit.
Now, they'll squeal even more depending on your couplings, and there are certain mechanics of the machine that can make it sound pretty aggressive.
Yeah, and that would be totally normal when you're performing this test, because that's what it's trying to do, to drive the machine to oscillation to get that maximum point, and then back it down from there.
Exactly. So then at this point, it's pretty straightforward. You're just going to kind of follow through the strategy. Keep selecting cycle start when it prompts you until we get to the end. We're not showing any real reporting as we go through. There was another selection that would actually pop up results. That takes a lot longer, but if I'm trying to kind of get through it, it's going to take what? We're 2-3 minutes into it now, I would say, and we're almost done. I think this is actually the last measurement that it will take. At the end, it's not going to implement any parameter changes until I tell it to. So it's going to give me a list of recommendations, and then it's up to me to then choose whether or not I want to select that. We're just about there. Yep, 100%. So now you're going to see it pop up the final. Oh. Did I lie to you guys? No, I don't think so. I think that was the last measurement test, if memory serves me. All right, yep, there we go. So this is where it starts to go down, and we can compare the original settings on the far right to the auto-tune settings, and then if you want to manually override any of the settings, you certainly can come in here and do that now. But if you want to apply these settings, if you're happy with them, hit the accept key. It's going to write those to the appropriate machine MDs or machine parameters. And now what it's going to tell you, potentially now, since I've only optimized one axis, and even once I optimize them all, it's going to try to take that axis and get the best performance it can out of it. But I could still have a synchronization issue like we were seeing in our egg-shaped circle. So when you get all done, what you then finally need to do is you need to define to the system what axes are going to be interpolating with, because you can only be as good as your worst performing axis. So if you got a machine that's only ever going to do what we consider planar milling, 2D style milling, and maybe my z-axis isn't that responsive, you don't have to include the z-axis in the interpolation if you're never going to do it with it. Adversely, though, if you want a 3D contour with the machine, you want to make sure you include the z-axis. So the way this works is you're going to use this final tool called interp path at the bottom. You go into interp path, and then you can select, there's a strategy section. You can choose which axis under tune you want to match. So let's say, for argument's sake, I'm only worrying about doing interpolation between my X and my Y. And nothing's going to happen here per se. What it's doing is it's comparing the machine parameters, and then it's going to adjust the parameters to balance them together, fully synchronize your axes. So it'll basically detune the more responsive of the axis to the weaker of the axis to now get matched so I can achieve the best possible circle that I can. So it's going to make a recommendation. I hit accept. It applies the adjustments. And if you guys want real quick, we could even maybe do a quick circular. I'm not overly optimistic right now because I didn't adjust or actually tune the x-axis, but let's give it a try real fast. So I can jump into circularity test again. Let's just make sure that we still have our circular program in auto. It is there. We'll get it started. So that's what we were at, right? That's where we were before. Let's see if we got any. Once the measurement's done, yep, there you go. That looks pretty round to me, huh?
Looks near perfect, near perfect.
But,
yeah, and another example of detuning the machine, certainly if you had like a fourth axis and you weren't really too concerned about super accurate contouring, you were using it for an index, then you wouldn't match the lag on that axis with the X and the Y axis, because that's going to slow everything down considerably.
And that's a very important statement. Rotary axes fundamentally are much less responsive than linear axes, right? So to do that, it's common on a lathe that has C-axis. The C-axis is generally nowhere near as responsive as the linears. Well, if you're never going to interpolate with that, why should you reduce the performance of all the linear axes? So you will choose different strategies based on the tasks the machines are going to do. You should have rights now, Steve, so why don't you jump in and let's get into I/O diagnostics.
All right. Wrong screen. Make sure I share the right screen with you guys here. All right.
Yep, we got you.
All right. So now we're going to get into the topic of the PLC NC variables. So a form of PLC NC variables are certainly the inputs and the outputs from the machine. So those can be viewed right on the machine, the status of those outputs. And you can even look at some of the outputs on Sinutrain, our offline programming system, as far as the keyboard's inputs and outputs. So this is just a little clip from actually Chris's machine, we're looking for the inputs so we can input those into the PLC IO diagnostics screen. And here they're designated here as I3.6 would be for the ATC home switch. I's are inputs and Q's are outputs. So down here we can look at some outputs for, say, the carousel forward. So we would enter those in exactly as we see them, and then that would give us the status of those outputs on the PLC NC variable screen. So this is a mapping of the keyboard, a standard keyboard from Siemens, which actually happens to be the one that's used on Sinutrain as well. So the inputs and outputs are designated for each key, so we can literally just plug those in there and kind of test our skill level on the inputs and outputs right on the offline simulator. If you are using a basic version of this the Sinutrain software, which means if you don't have a license, you do have to make sure that you use the template machine in order to gain this functionality. You will not have this functionality if you're using the demo machine. The way that we navigate to the PLC NC variables is, again, selecting either menu select or the upper right hand corner. If we select this area here, then that'll get us to the diagnostic screen, and from there, when we press NC variables, we'll see a screen similar to this one. This one's already been populated with some variables, so what you initially would see would be a blank screen or whatever was in there from the last time that someone was using this machine or using this feature on the machine. So with that, we're going to pop over to Sinutrain real quick, and then that's going to give us the ability to look at some of these features. So here we can see I'm already in this screen, and I've taken the liberty of loading some of the IO manually, but I want to also pop up this screen. And so this is where I got these values from. Like Q, that's an output, so that's the light 1.7. That's the feed start light. So that would be from pressing, let me move this over just a bit here, feed start. Oops, sorry about that, wrong one. Let me move it back. So here we have the feed start, and we can see that the status up here changes whether we turn the light on or off. And then we also have like the spindle start, which is I2.5, as designated over here on this screen. So if we were to do the spindle start, we can see the status of that and the light as well. And then here we're looking at the spindle override. And these inputs can be designated in different ways. So in the sense of the minus key, input 4.6. So if we select that, here it's designated with the data blocks and data bits, which is directly from the way that the PLC would designate it, and then also by just the actual description of that key. So it's also important that you can insert these variables by going right to the insert variable key. And then you can filter the variables by all these different categories. In this case, we're going to use the PLC, and then we selected reset. We're going to take a look at the resets key, and then here it designates the actual data bits or the data blocks that it's using. But if we go down to the bottom and we see this channel reset, which would be this one right here, and if we go add, then it loads it right into the screen for us. So as we press the reset, we can see that the value, of course, now this would happen to be the wrong one. Let me go back down and correct that real quick. channel reset. I selected the wrong one, but as we can see, that then it's all changing accordingly. So it's important to note also that you can save these masks and then load them in automatically as well. We close that. So with that, we're going to go right back to Chris, and Chris is going to demonstrate how that can be used right on the machine tool itself. So back to you, Chris.
Perfect. Well, let me just share up my screen here. Okay, so as Steve mentioned, a great way to start to validate if you're getting some form of maybe inconsistent behavior on the machine. A good common area where you could kind of see this is you're in process, the machine's running, and she just pauses. And maybe it's hung for a second, and then maybe it starts to move again. A lot of time, we're not sure what could be causing that. Well, believe it or not, it could be something as simple as just maybe a door proc switch is not staying closed fully or on the hairy edge of that input. So how could I see that input is bouncing? How do I see that safety proxy to validate that the doors are closed or my air pressure is sufficient or a number of things? I mean, there's all kinds of inputs in the system that's checking to make sure that things are where we expect them to be, whether it be something as simple as the state of a door, something as complex as a tool changer is in a safety location, right? So we can start to go through that process. Now, a common area where I would say you can start to see this certainly would be in tool changer functionality. So what I did here is if I navigate over to my diagnostics screen and I go to my NCPLC, I got us ready to start to look at some of the tool changer I/O that is specific to this machine. We didn't really look at it in detail when Steve showed the print, but if I take a look at my print, I have some input bits that are tracking as my carousel spins or rotates. That's counting my Geneva drive. I have input bits that are validating when I send the carousel underneath the spindle that I've achieved a proper location before I move to the next step and continue tool change. Same thing with backing out. Now, as Steve mentioned, you do have the ability of having these input bits preloaded for you if you want to create your own what we would call masks or files here. In this case, I just had a bunch of inputs that I had been using for other testing. So let's assume I was a service guy, came up to the machine. I want to take a look at the tool changer status on this machine. Well, I can do it off my USB. Let's say I had the USB in there. Expand my vertical soft keys to go to the load mask. Additionally, how I made the mask was I did a save mask. So previously, I came in and I built a mask for us that had just those I/O points. So that could have been saved or loaded from a USB. I have it here locally. But this is really handy if you're, if you want to kind of create a few different files that goes through all of the I/O that I typically would want to monitor on my given machine. Now there, I see the current state that it is sitting in right now. So if I happen to know, well, I would expect to maybe I 3.2, if we look at that as my carousel out. Now you see, right now I have no reference of what that is. It's just an input. You can even give it comments. So there I see with my comment screen, carousel is in an out state. Now I did type in these comments. It's not going to happen automatically. But once you fill them out and you save this file, it will carry with the file. So it's pretty logical to think my carousel is in an out position that I would have that bit at a 1, and the carousel is not in, so it's 0, but I may not know the timing or the logic that was developed here. So we can send this machine into a quick little tool change program, and we can watch the state of that I/O. So I'm just going to load it in. This is just simply going to flip through a couple tools. Doing that, I'm going to go back to my NC screen. I have a little delay here as it's waiting to do the next tool, so just give it a second. So now it orients. You see my carousel in changed to a 1, out went to a 0. Also, and we'll watch that counter bit on the top. So when we go to do the next tool, as it's counting, now this is what's called a Geneva drive system. So socket is going to count a location. Now in that case, I didn't see the count, probably because the status of this isn't quite fast enough for that. So there are other tools in the system, and see, I'm just kind of getting it, that we can even look further. But this is certainly a great start to validate the state of some I/O. Now you can also look at the state of outputs, as Steve mentioned. In this case, I'm only looking at inputs, but if I knew what I/O was firing the solenoid to tell the carousel to move forward, of the puzzle that really make a tool change occur. And when I'm having inconsistent problems, like maybe my machine's not tool changing all the time, I would want to validate each of those steps. Okay, so I'm going to let it finish up this tool change. Any questions from the NCPLC side, Steve?
So, Chris, you had mentioned that you can look at it a little further if you wanted to see the status of the I/O, or let's say the timing of the I/O, to look at multiple I/O and actually look at the timing. Do we have time maybe to get into that a little bit?
Well, why don't we scratch the surface? Probably don't have enough time. I see we're already almost a quarter past the hour here to go in detail. But we could certainly use it as a primer for maybe an upcoming 302 seminar. But yes, we have a function in the control we call trace. So if I expand from the NCPLC screen to beyond, there's this function called trace. And what trace is think of it like an oscilloscope, right? Has any of us used an oscilloscope before, where you got your meter and you kind of, you're watching some I/O bits? Well, you can set up your I/O state, and then you can actually create a trace and watch the status of what's going on. So here we can try to, let me get this thing running again. Oh, there she goes. So now she's tool changing. We'll go back. It looks like I had been playing, and I probably have some I/O in here we can use. So, all right. Here's our setting. So we can start a trace. And what it'll do is it's now going to start to monitor those I/O bits and show me different stay on and stay off. So if I'm really getting into timing issues, I really want to start to see kind of exactly what's happening, more so than just viewing it from the PLC monitor. This is a really handy tool. And this goes way beyond us just scratching the little surface of this. But certainly that one method to start to look at what's happening in our system. Now, the other method, which is kind of interesting, the 828 and the 808 also have the ability of viewing the PLC at the control. So here, if you wanted to, and I do always suggest proceeding with when it comes to the, but in setup, you can go to the PLC button, and this will actually open up the PLC project. And then from there, you can start to go in and look for the appropriate PLC block that may have the logic that we're looking at. So you can do that, but specifically we allow that functionality on our lower technology controls, our 828 and 40. We do not have an onboard PLC viewer / editor when you get to the 840 or the SINUMERIK 1. So with that being said, Steve, any other questions before I switch it over to you and we start to actually go through some of the questions from the audience?
Yeah, so one other quick question. You don't have to go into detail about it, but let's say if you wanted to force the status of a bit, is that possible to do through the PLC NC variable screen or through the PLC?
It is. It is certainly in both cases. You do have to watch out for in the NC PLC variable screen. That's a good point, though, because it depends on what the PLC allows you to do. So there is a lot of I/O that the PLC will limit or restrict you from being able to override. But that's what this change button is intended for, right? So maybe the door switch and it didn't quite make, and I wanted to try to force that switch to make the PLC think it was actually in a good state. You could hit change, and then you could actually override the value. You see how I said okay, mine immediately went back to a 1? That means in this case, the PLC is not letting me override it. But that's what that change button's for. So time run into cases where that was handy to try to just kind of fool the system in thinking it was a different condition to try to diagnose my problem.
So generally, if it was a safety type issue, it's not going to allow you to force the status of a bit if it could result in a crash or something along those lines.
Exactly. Correct? Yep, I would agree with that.
Okay, great. Well, thanks for those explanations, Chris. Sure.
No problem. So we're going to hand you control real quick, and then we're going to go through some questions here. So Steve, you can share the last slide.
And the last slide is a very important one because that's where we get to the questions. So
perfect.
So have we got it?
Let me start. Yeah, we got a bunch of questions. I gotta dig through the Q&A in the chat, and certainly there was some questions about the choppiness and stuff. So I'm going to have to muddle through that. So let me start with asking you. So what was the Q on the variable screen, they asked?
So the Q is an actual output, and that's an interesting question too, because we designate inputs as I's, so why wouldn't we not designate outputs as O's, right? Seems logical. Well, the reason we don't do that in the Siemens PLC is because O means something entirely different. That would be used as an operand in the Siemens PLC. So that's why we use Q's instead of O's. But that's a good question.
That is a good question. All right. Can you save those inputs and output masks to the USB? And then it looks like, oh, never mind. We answered it. We did. To reiterate it, yes, you certainly can save the mask that you're creating for the NCPLC to the USB, move it to another machine, bring it in. But you would want to obviously stay with that series of machines because OEM to OEM or model to model, nobody says that the same I/O point has to be used for the same function. You certainly would expect it if you walked in front of another one of my CM20 machines, probably using the same common PLC and logic there, but it may not be for a different model machine. So just be cautious of that. But I would expect, you're going to want to compare it to the schematic and make sure that that all seems to match. Okay.
And one other important point there too, different builders may designate their IOs differently just because in the standard PLCs with Siemens were I's and Q's, but different builders may have their own designations as far as the IO, so that may differ. But you still should certainly be able to use the PLC IO screen on the control to analyze those conditions.
Okay, so now we have a question from Greg here. What's the best way to compensate for the twist of ball screw? The backlash that shows only on small moves, a couple of thousandths, but not if I move, say, 10 thou. So I believe Greg is probably referring to ball screw comp, is how I would read that question. So there is a whole set of other machine parameters that allows the system to compensate for any deviation in your ball screw, right? When a ball screw is ground or manufactured, it's going to have some kind of error. It's not going to be 100% perfect. So what a builder does, typically, is they will laser shoot the machine. They'll use a laser, and they will calibrate it, and they will take measurements over the length of that screw. And from there, those data points will be plugged into a ball screw comp table. So when I tell the machine, hey, move 10 inches, well, if it knows that when I get to 10 inches, I really got to adjust another 5 thousandths because the screw, there's a little inaccuracy in the grind, that ball screw comp table will compensate for that. So I believe that sounds right, Steve?
Yeah, that sounds right. And some of those tables, the ball screw comp tables, will be unidirectional or bidirectional. And I think it's important to point out if the machine is equipped with bidirectional comp, then you're not going to use the backlash value in the MDs that we were pointing to, because that's going to fight it. That's going to work against it. So if you have bidirectional comp on the machine tool and it's been activated, then you would not use the backlash compensation value in the machine data because it's not necessary.
Yeah, absolutely. And actually that brings up another good point that we didn't really mention. Same thing with scales, right? So if you have glass scales, so if you're seeing backlash in your machine, that is probably indicative to a mechanical problem. And it's not uncommon. I've seen it a ton of times. Steve, you could probably back me up, where the reader head starts to get loose over time, the mounting bracket, right, that mounts to the machine, and now all of a sudden it looks like I got backlash in my scale. It's because the reader head's flopping around, and it's really just a matter of tightening up a couple of bolts. So you always want to really understand the hardware that makes up your machine before you assume implementing one strategy over another. Now, if you get a case where maybe the mechanics of your reader head always have a little bit of distortion because it's so far out from wherever it mounts, then you could use backlash to compensate for that. But a general rule of thumb, you should not need backlash with glass scales.
Yeah, I would agree 100% with that.
Okay.
In theory, at least.
In theory, yeah. There are always exceptions to the real rule, for sure. Now we got another question. It looks like it came from Chris. Are the circular and backlash test standard features, both the 828 and 840D controls? Yes, that is true. Everything we showed you here was a standard function. Now it will take different access rights to use. So we do that intentionally. So a user that's just working off the key switch can get in and start running auto server tuning for argument's sake. But yes, these are all standard functions within the control. All right. So Greg actually referring to his previous question about the ball screw. He was not referring to ball screw comp. It's when the ball screw just twists on a small motor shaft angles. Not sure I'm completely following. Greg, maybe we'll have to take that one offline. We can talk about that separately. Okay. This is coming from Spike. As I recall, if a builder selects the German mnemonics in the step 7, the IO will show as an E or an A. I don't really know. Do you know that, Steve?
Yeah, that's correct.
Oh, there you go. I learned something today. Okay. Oh, no, then Greg turned around and said, all right. Yep, you can do it using ball screw comp. Okay, no problem. All right, so I think I got those. Let me see what other questions came in, maybe under the chat. Okay, we got a lot of questions. Does backlash comp affect bidirectional comp? So good question, good point. This came from Dan. So you want to be very careful if the system has bidirectional comp enabled, that you don't, or you're very cautious as when you apply a backlash. So bidirectional comp is an interesting thing, right? We were talking about ball screw comp the measurements in one direction. And Steve, you mentioned a little bit about bidirectional comp. So bidirectional comp, you'll have two separate tables, right? We'll have a table of measurements in one direction, and then a table of measurements in the other. So basically what that gives you is having almost like a variable backlash. So you can find on certain machines that the backlash is different at the extent of its travels than it maybe is in the center. That can all be compensated with bidirectional comp. But if you implement the regular backlash, now that's going to stick on top of the bidirectional. And if you were doing it because maybe you're compensating for extra wear in the middle of the table, it may overcompensate your backlash when you get to the outside edges. So for sure, be cautious. If your machine was commissioned with bidirectional comp and you do have backlash comp, then you're going to want to check the value over the length of the screw. And if you have a common value that works everywhere, certainly you could try to apply it, especially if your machine's getting older. But probably the best case would be have it recalibrated with a laser. Wouldn't you agree, Steve?
I would agree 100%. That should be done on, depending on what type of accuracies that you're expecting out of your machine. That should be done on a somewhat regular basis, at least every year or so. Or of course, if you're changing some major components on the machine, for sure the ball screw itself, then the previous comp would be invalid. So that's definitely.
Now, Brett asked, is there a place where we can download your circular interpolation ion program? Okay, so if you're talking about downloading the circular interpolation program that was created by the machine or by the utility, it's an editor. The auto real quick. No, I already closed it. But I'm not sure if we could pull it out. The actual program that caused the motion. It's in there somewhere. We probably have to find a file. But on the other end, if I'm misinterpreting your question, if you're referring to the actual plot of the circle that we get, that graph, that absolutely can be saved, pulled out. So if you're out doing testing and you want to capture and save that, that measurement for maybe your report or future reference, that can be pulled right out of the control for sure.
So, Chris, one other point on the actual program for this circular interpolation, that is accessible right through that's just in the program folder. It's accessible just like any other program. So I have seen it in there. That's where it goes to. So.
Gotcha. Just reading some other ones here. So Steve jumped back and said that Greg may be referring to friction comp. That could absolutely be as well. So friction comp is another form of compensation that allows us to overcome certain stick slip that you could see when you're moving into an axis directional change. So that actually goes back to the graph that you showed us, Steve, where we were seeing that opposite spike. So for us to overcome that, we can, if we can anticipate that this is always going to be a condition that the machine has to overcome, we can actually compensate and try, almost overexcite the motor a little bit to counteract that behavior. So that is another method of compensation that we really didn't get a chance to explore today. Okay. Correctly. All right. Oh, it looks like Jim was mentioned that he heard that I am in New York. That is true. Jim says he's up in Rochester. So I am actually down closer to New York City, about an hour north of New York City. So just far away from the riffraff, as I like to say. All right, good. I think I got everybody. I may have missed some. Yeah, it's always tricky, but if I did miss any questions, I do apologize. And for sure, shoot either myself or Steve an email. You have Steve's email address there on the screen. You had mine earlier. I do want to thank Steve for putting this webinar together. I certainly enjoy getting a chance to work with you on these. I think it's fun getting to go back and forth a little bit. So thank you, Steve. And I want to thank everybody for joining. Steve, I'm sure you probably want to thank the audience as well.
Yes, I would like to thank the audience, and also maybe this is kind of a new system where, for our webinars, where we're kind of going back and forth with some live demonstrations. So by all means, let us know what you think of this new this new type of webinar that we're doing, if you like it, aside from the audio difficulties that we were having.
We'll fix that next one.
we'll work on that.
But we'll buy a better mic.
It would be good to get some feedback to see whether if it's working, if they like it, or what.
Absolutely, I couldn't agree more.
Yeah, but yeah, thanks everyone for joining us, and again, thank you, Chris, for all those demonstrations. I think they're very useful to actually, instead of just talking about it and showing slides, being to actually show how it's being done on a real machine in real time. So
absolutely, my pleasure. Great. Well, with that said, again, thanks, Steve. Thanks, everybody. Enjoy the rest of your day. Enjoy the weekend, and reach out if you need us.
Yeah,
have a great day.
And always stay safe.
And always stay safe. Couldn't say it better.